We are looking at antiderivatives. Okay, I want to make sure we're clear here because there was a lot of confusion yesterday. Okay. It's the antiderivative of cosine, right? Okay, I think you're okay there. That's the sense I had yesterday. My worry was where we added a function inside there. Okay, but some of you have it. I think about half of you, but there's half of you. This is really easy. Of course, it's sine. No.
Randy Leonard down to check out.
Yeah.
Thank you.
I have no idea. Watch the video. Hopefully you'll get it.
I'll get an automatic reaction.
I think she heard it too. All right. You got to compensate for that by dividing by the derivative of what's inside there. Okay. The reason is the chain rule. Okay, if you're going to take the derivative of this, you would have cosine, copy inside, but then you take the derivative of the inside and multiply it, right? Which is 3. So to counteract that, because it's not here, we have to divide by 3, right? So if you're going to go backwards, you got to be able to think backwards here on antiderivatives. So hopefully that helps. The same thing's true with cosine and sine and e to the x. If there's a function in the exponent. Okay. Copy it and then divide by the derivative. Okay, it's the same issue. Yes?
On our homework, we had one where it was like 12 secant x tangent x. So what do you do when the number is already before?
Oh, you just leave it.
You just leave
So
it?
if I had like a 4 here,
Yeah.
it would just come out. The rule is, and I don't ever really go over these formally, but you can rewrite this as 4 times e to the 2x. You can rewrite it like that. So it just transfers. Yeah. Sometimes this actually helps. So, all right. So hopefully that helps some of you and keeps this straight. We're gonna figure out how to calculate c today, the constant. All right. So we don't have to worry about letters being in our numbers. Okay. All right. And we're gonna write it a little bit differently. So if I asked you, and this is completely because it is an antiderivative. Is that the 7th? That's a 4. This is a y. See the difference?
Yeah.
It's got a cute little tail on it. Of course, this one doesn't, so hey, how about that? All right, so we've written this differently. This is the same as if I could rewrite it in calculate. Okay. We're going to rewrite it as the way we've been doing these problems. We would want to say calculate okay, this is another way to write it. Okay. This is called, okay, this is a derivative, right? So how do you find the original? Take the antiderivative, yeah? right? So that's kind of the mind frame we're trying to get you in. And we're going to get to something, and we're going to start calling these differentials. Okay? So you might want to get that vocab word in your melons. For differential. Okay, you've seen it with implicit differentiation. We're going to use it with something. We're going to use it a little more extensively to solve for these. So later, after this is the last thing we do for the year. So these are the same question. Okay, so anybody? What does this equal? Right? Now, we're going to write out y equals. Because we've taken the antiderivative of a derivative, right? So we've undone the derivative. Now we're at the original function again. Okay. So this is, we're going back and forth here. We have undone that differential. Now it's y. Okay. Yeah, now you have an x value and you have a y value. You plug them in and solve for c. Okay, so 4 times 0 to the 8th. Oh man, they made this one easy. Yes, we did. So 4 is c, right? What's our function? Yeah, y equals 1/2 or over 2, it doesn't matter, plus 4. You have just solved that differential for the original function. Okay.
So it'll ask to solve the differential?
It will ask to solve for the
I'm
differential.
sorry, I can't talk.
Usually, never mind. I can't talk. It's kind of a bold statement. Yeah, so we've solved the differential using an antiderivative to find the original function. Okay. Math lingo. All right, let's look at another one there just to make sure you. Another one. Guess what? It's probably harder, right? Solve dy dt equals sine pi t with y of 2 equal to 2. Well, see how that's dt on the bottom, and that's a t? It's the same as saying dx and x. But no, it's differential dy dt, the derivative of y with respect to t.
If it's an antiderivative, then the x is in the bottom.
Yeah, whatever letters in the bottom should occur out here. Yes. Does that make sense? So this would be t now, and this would be still your y value. So just think of this as an x. Okay, there's no difference. It's just saying it's something. We don't know what it is. So another way to write this, and we'll do this, would be to write it like that. Okay, so if you think that's better for you, we're going to use that later this year. So you can use it. Instead of rewriting it, you can just throw those on there. The antiderivative of dy dt is y. And what's the antiderivative of sine? Is it? Negative cosine over pi. But don't forget that.
Which is basically
Wait, don't you have to multiply it by pi?
Yeah.
No, this is an antiderivative, so we divide by pi.
Oh, yeah.
Remember, derivative means multiply. Okay. And then plug your initial condition in and solve for c. Okay. So the y value is 2. Cosine at 2 pi is really 1. Thank you. It's so negative 1 over pi plus c. Add that over. So there you go. Don't worry about decimals or anything. All you can do is screw it up. You might, but they have the answer there, so it'll be pretty obvious. So y equals negative cosine pi t over pi plus 2 plus 1 over pi. Good enough?
So you just plug it into the.
Yeah, it's the constant. Plug it
Plug your C value
into the function y. Yeah, after you calculate the antiderivative, right? Are you okay with that? Jogging memories. Okay. Try these without a calculator. Practice your unit circle. This is a completely no calculator problem on the tests. Okay. All right. One more. We're going to look at a motion problem. Woo! Okay, let's write it out. A car traveling with velocity 24 meters per second begins to slow down at t equals 0 times 0 with a constant deceleration come on, keep up, board. The constant deceleration a equals negative 6 meters per second squared. Find, okay, so this would be part A. V of t at time t. No, we'll start there. Uh-huh. Yep. Let's make that better. Okay. Any ideas? Okay, remember your motion relationships. Okay, we had position. What's the derivative of position? Velocity. And then acceleration. No, okay, so we've been going down. We've been taking derivatives using this. Now we're going to go backwards. So what are we given? Okay, we're asked for velocity, right? Given acceleration. And that is an initial condition. At time 0, the velocity is 24 meters per second. Okay, so this is your initial condition, and you have an acceleration function to start with. So the antiderivative of the acceleration will give us what? The velocity function. Yeah. Yeah, so negative 6t, because we're in time, it's the x value. So this is v of t. Yeah. Never mind the units. Okay, for now. You're okay there? Acceleration, velocity function is the antiderivative. So now I can plug in my initial condition to solve for c. So v of t is negative 6t plus 24. We like that. Right.
So if you have to plug in T now, but you know, so 24.
Say what? Repeat that. No, it's okay. Here, are you here?
Yeah.
You understand the antiderivative?
Yeah.
Yes. Okay.
So then
Yes.
plug in T.
Velocity is 24. Time was 0.
Okay.
Calculate initial condition.
So then you have to plug in T again, get your final in there.
No,
No?
it's a variable. Time can change, right? That's why we leave it t. Okay. So using antiderivatives to go from acceleration to velocity, right? Let's say find the distance traveled before the car comes to a halt. Car to a halt. Okay, you have to decipher these. Mhm. Okay, so right, you can write it like that on a free response because you've defined v of t. Okay, but you can also write this. Okay, I'm perfectly okay with either. As long as v of t is here and you're good to go. All right, so we are looking for the position function, right? It's a distance function.
So negative 3T squared.
You see what they did there, right? Added 1 and divided by 2, so it's negative 3. Okay. Plus t. Okay. What's the initial condition? No. 24 is a velocity. We are now working in position. Right. So we're gonna consider the starting position 0. So that next time this parabola, you know, this is a parabola, right? So if this is 0, 0, the next time it hits, it's going to give us how far it's gone. Okay, so 0 is, okay, what's C? C is 0?
Wait, so you plug you plug
Yeah.
0 with S of T and T?
Yeah, it was because at time 0, we are considering the distance 0, the position 0, right? Because if we figure out where else it happens to be 0, good to go. Okay. So we found C, and our function is right? Now, the question is, How do we calculate distance traveled?
You find when D of T is equal to 0.
Okay, here, yep, yeah. This is the key on these. How do I know when this car stops? Because it's coming to a halt when velocity is 0. Okay, so we have to figure out what time this happens and then plug it into the position function to give us how far we've gone. Okay, so minus 24, T is 4. And what's S of 4? So we're here, and then we're here. 4 squared is 16, so we have negative 48 plus 96. 48 what? Meters. If I were president, we'd be in the metric system. It's a good thing I'm not president, I guess. I would do pointless little things like that just to make people mad. My first State of the Union address. I'm changing us to the metric system. Have a nice day. No, just kidding. Okay, you okay with that? So again, we started with acceleration, and we built the entire model of what's happening with that car. We've calculated velocities, positions, a whole bunch of stuff. Okay, these problems will occur quite often. This is you're probably looking at maybe a free response on this stuff on the AP exam. We'll look at lots of them, so make sure you have this down pat. Okay, that is it. A lot of this stuff, and that's calculus in general. If you can figure out, oh, I need the derivative set equals 0, you can usually calculate those pretty easily. You just have to figure out what you need to do. Yeah, so
If you don't know what you're doing, just set equals 0 and you'll probably get the answer.
it's possibility in derivatives. Yeah.
We don't know, just find rules. You'll get like.
Really? Yeah. The goal, there are 9 points per free response, right? The goal would be to earn on 4 points each. And that gives you 24 out of the necessary 40-ish points to earn a 3. And you can usually come up with that. Okay. All right. Do I need to write the work down again? Because it's awful long. You good? All right. Due tomorrow. Hopefully you've been working on it. Or is my faith misplaced? Okay, tomorrow you have a quiz? Yes? It is 1 applied optimization problem, and it is 3 antiderivatives. Okay, and then, no, it's open. It's open. And open free response. Okay, and the rest of the week we'll be doing some activities to hopefully solidify your understanding on the relationship between F, the graphs of F, F prime, and F double prime, and their verbal relationships and their tabular relationships. So no more notes for the week, Logan Waterman. Your request was heard. Yeah.